Hi, hey guys. This is JJ Good, and this is GPA data analysis, our project that we worked on in MATLAB. So here's an introduction. We are studying the ecosystem of student successes by major, looking beyond factors like time investment and retention. What made us choose this topic? Certain majors are aligned to higher workloads, lower GPAs, or increased dropout risks. Why? And then scholarship and job requirements often use fixed GPA cutoffs that don't reflect major difficulty. And then we decided to gather data on GPA time spent just because me personally, I know people who barely do any work and they have such a high GPA, whereas I feel like for me, I do a lot of work and it's really hard for me to just keep a pretty decent GPA. So here's Michael with the next couple slides.
Thanks, JJ. So how we went about this, our methodology for completing this project was, first thing we did was obviously find our data sheet. There was a huge study done at UC Berkeley looking into average GPAs by major. And in the study, we found a pretty massive data sheet, which was super helpful for our project, kind of the backbone of all the data we got. So what we did was we took that data sheet, we put it into a Google Sheets, and basically had the first column be all the majors and the second column be the average GPA for that major. Then once we had that simplified down, we imported that into MATLAB and had it read off, majors are in this column, GPAs are in this column. And that allowed us to categorize it and then write code that had MATLAB visualize it for us. So if you look on slides 4 and 5, slide 4 is our average GPA by major, and slide 5 is another study that we got, another data sheet that we got and eventually added into our Google Sheet of average study hours by major. And so our first thing that we did was, once we had everything categorized and in our code, was create our curve formula. And so that curve formula was the raw GPA, so the student's GPA, plus the target average minus the total average. And so how we got that total average is just taking all the GPAs that we had from our data sheet and dividing it by however many GPAs we took. Pretty simple. That target average is going to be whatever the average GPA is for the major that the student entered. So if they enter mechanical engineering, the code goes and finds mechanical engineering and finds the average GPA for that. And so by subtracting those two, you get how much you need to either add or subtract to the student's current GPA in order to give them a curved average that'd be more fair to everybody. And so that was the first step of our problem. And then as we finished that, we wanted to add a little bit more. And looking at these data sheets that we saw, we'll talk about this a little later in the presentation, but we saw we saw that the study hours and the GPA weren't correlated. And so in order to improve our curve formula, we actually added in study hours into the curve as well. So I'd have to double check exactly what we put. I believe it was 0.2, but for every extra hour a week that the students studied, we added 0.2 to that GPA curve as well. So same thing with that total mean. We took the average work hours per week and then subtracted it from how much that major was expected to study and added that to their GPA as well. So once we had all that code, all that those formulas in, it was pretty easy to just have the code prompt the user to type in their name, type in their major, type in their current GPA, take that, put it into the formula, and output the curved GPA.
Thanks, Michael. So our correlation for the project, it actually ended up being the same as our previous report, but it was at a negative 0.42 correlation, which meant that for every hour per week, our GPA actually went down 0.025 points. So you can see on the graph right here that the higher up you are on hours per week, the lower your GPA will end up being. And then majors like chemical engineering and architecture, they show a high time investment, but as you saw in that last graph, the higher time investment, they have a lower GPA. So do their GPAs justify their effort is what we think is a moderate GPA, like pretty good, solid level 3.2, GPA 3.3, in these high workload majors. They should say that the student's highly motivated, so they should get rewarded for doing well in these majors. And then some code we used, so we loaded in all the data sets, and I believe we had 3 or 4 data sets that we had to load in. And then we had to find our average GPA using a group summary code, and then we sorted it through rows to find which row the GPA or the major was in. And then our biggest problem, I'll talk about it here in a second, but is in that major stats code. So with our average GPA and adding the hours together, we weren't able to talk about both only divisions of things, meaning like College of Engineering or College of Business and Arts and such things. We were only able to talk about majors and only the certain majors we had listed. So then, I'll talk about that later, but we used the bar H, which is just a bar graph, as you saw in the previous slides, and this is our code for the bar graph. So we were able to do what color we wanted, how big we wanted them, and able to do the limits for the GPA from 3 to 4 there. So some challenges. So our biggest challenge really was our pivoting late in our process. So we had the idea of talking about a certain video game and trying to figure out how money was involved in the game. And it was too much data that we would have to figure out ourselves. And then so we transferred to this idea of the GPA curving. And then our big problem was pulling all these data from all these big data sets. We ended up having like thousands of lines of data that we had to sort through and make sure everything was lined up, and then making clean tables and graphs. So for the previous one with the majors, if we didn't have the weekly time spent, it was every single major that was listed on the other, and there was upwards of a couple hundred majors. And so we did it with the weekly time spent to where it would show up only 25 majors. But that bottlenecked our data, like I said before. So we were only able to have those 25 majors, or however many it was. So you can't input any type of engineering, or like we had like art, architecture, blah, 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 all these things, but only those. Like we couldn't add in a degree of, what was one? It was mechanical engineering. That was a big one that we couldn't add in because it wasn't in our weekly time spent. So our biggest challenge was that bottleneck of data. And then with bottlenecking the data, like I spoke on before, was the separating our data by division of college rather than by major, like we previously thought we could do, but it ended up not working because when we did by college, we were only able to get these 4 points here on the side. So thank you. I'll let JJ end it off here.
All right, thank you, Lucas. So to wrap this up, what can we do? Having our outcome apply a fair curve for all majors, we recommend mandatory advising for high workload majors to teach time management and proactively address burnout risk. Joining programs with strict guidelines help teach students to be better learners and knowing when to ask for help. As you can see with all this information, it's showing the harder the major is, the more time you have to spend on your major, the more time you have to spend on your major. Weirdly enough, you have a lower GPA. So learning to manage your time well and knowing when to ask for help, that really helps with your GPA. And so for our end goal, we believe that we have reached our end goal of creating a program where students can see their curved GPA based on factors like hours spent studying a week in what majors they are. If we had more time, we would have liked to find even more data on study hours and incorporate that into our MATLAB. So I believe we did a pretty good job with our coding. You can find out your curved GPA pretty easily with using different factors, which is pretty cool. And I had fun doing this project alongside Lucas and Michael, and yeah, we had a good year. Thank you.